Hi everyone, welcome back to our channel, and today we're going to learn how to simplify radical expressions. By the end of this lesson, you'll be able to simplify radical expressions by factoring radicands. Let's start by understanding the most important terms. First, we have the radical. This is a symbol, this one in green, that represents a root of a number. Next to it, we have the radicand. It is the number or expression inside the radical symbol. So based on our example here, 50x is our radicand. It could be a number alone, a constant. It could be a combination of both here, like the 50x coefficient and a variable, or just variables themselves, aside from the coefficient of 1. Now next is the index or the nth root. This tells the type of root being taken. It is the small number written on the radical symbol. So for example here, now the cube root of, let's just say 20y. So as you can see here, this one in green is our index or nth root. However, I know that you're familiar with this, the square root of, let's just say 25. Now, based on this, there is no evident index or nth root here. However, if you cannot see any number or nth root of a radical, that means it has an invisible 2. Because again, it pertains to square root in connection to perfect square. And I hope that's clear. Next, we have the principal root, which is the non-negative root. For example, if we have the square root of 36, in the world of integers, we know that the answers for this are positive and negative 6. Because again, we have 6 times 6 is equal to 36. And at the same time, negative 6 times negative 6 is also 36. However, as you can see here, based on the definition, it is the non-negative root. So basically, we only take the positive answer. So for the principal root of the square root of 36 is only the positive 6. Now, let us have some examples for us to factor out or extract the roots, perhaps. So we have the square root of 25. So for this one, again, let's just take account of the principal root. So the square root of 25 is just the positive 5. Just to recap for some, again, you can change this into 5 times 5 or change this into 5 squared. Remember that a square root can cancel a square and vice versa. Or let's just rewrite this. Square root of 5 and then square it. Again, a square can also cancel a square root. Okay, it just makes sense. So based on this, the number that is left after canceling stuff here is 5. That's why we get to have 5 as an answer. Next, let's have square root of 50. As you have mastered sum of the perfect squares and perfect cubes, or let's just talk about perfect squares. We know that 50 is not a perfect square. So what do we do with this? All we need to do is to have, let me just illustrate a thing. A and B. A here should be a perfect square. And B is a non-perfect square. Of course, if we are going to use a cube root, we should also use a perfect cubed. Anyway, let's focus on perfect square for now. Now, based on this, think of a perfect square in which when you are going to multiply it with a non-perfect square number, it would lead to 50. So based on this, if we try to have 4, let's try 4, because obviously if you're going to have 1 and 50, it doesn't make sense at all because the result will just be 50. And our goal here is to factor or extract the root out. So let's start with 4. I know that some of you who are watching this might have the answer already, but just to give sense for others who are still managing to find the answer. So if you have 4, which 4 is a perfect square, obviously. So if we try with 10, perhaps. I went to 10 because obviously if you multiply with 9, it's 36. So if we try to multiply it with 10, it's 40, and it's close to 50. So this one is square root of 40, which is still not close to 50. So 4 times 12, we have 48. 4 times 13 is 52. Based on this, it didn't work out, so we need to go over to the next perfect square perhaps. This one here is wrong. So let's try 9. So 9 times, let's just say 5, because 9 times 5 is 45, so it's really close. However, if we try to have 9 times 6, this one becomes 54, and it's over 50. We only need to get the exact number or the exact radicand for this one. So also with 9, it doesn't work out as well. So let's erase this one. Let's also try 16, which is also perfect square, times 2, which is 32. Okay, let's have more. 16 times 3 is 48. So 16 times 4 is 64. So it went overboard as well. Again, our goal is only 50, so 16 doesn't work as well. Let's erase this one. Now, next number would be, next perfect square would be 25. So 25 times 2, which is 50. So based on this one, the numbers that we are going to use would be 25 and 2. Now let's work out this one. Let me erase these. Now based on this, we'll get to have 25, a different color, 25 times 2. Again, 25 is a perfect square number, and 2 is not a perfect square. Again, we base it on square or perfect square because we're using square root. Now, the square root of 25, for all we know, we're just going to take account of their principal root. So as we extract 25, the answer is 5. And since 2 here is not a perfect square, that means it should remain inside the radical. So the answer for this one is 5 square root of 2. Okay, so the square root of 50 is 5 square root of 2, and I hope that's clear. Let's try another example. Wait, let me add a thing here. So we have square root of 72. So think of a number, a perfect square number. Let's label it again as A, and a non-perfect square number that when you multiply the both of them, their answer would be 72. I will give you 10 seconds for you to think of it. Time starts now. Alright, so based on this, you could use 36 and 2, because as you multiply both numbers, 36 times 2 is 72. So like what we did earlier, extract the principal root of 36, which is positive 6, and then leave the non-perfect square inside the radical. So The answer for the square root of 72 is 6 square root of 2. Now let's have square root of 48. Okay, so earlier it was easy for us to have 50 and 72 because we could just divide both of them with 2. So 50 divided by 2 is 25. 25 is a perfect square number, which made it easy, similar to 72. Now, let us try 48. So 48 divided by 2 is 24. However, 24 is not a perfect square. So let's use other numbers. Divided by 3. So 48 divided by 3 is 16, which is a perfect square. So we could use this one. So basically this is 16 times 3. And again, the square root of 16, let's just have the principal root is 4 and leave the non-perfect square inside the radical symbol. So the answer for the square root of 48 is 4 square root of 3. Now let's have square root of 98. I will give you 10 counts for you to figure out what are the perfect square and non-perfect square numbers that we're going to use for this one. Time starts now. Alright, so let's try dividing this by 2. So 48 divided by 2 is 49, which is a perfect square number. So it's easy for us since we applied 2, divide 2 with 98. So square root of 49, a perfect square, and a non-perfect square, which is 2. And again, extract the square root of 49, which is 7, and then square root of 2. And that's it for this item. Now, let's try to apply an example where coefficient and a variable are present. So let's have this one. Square root of 18x squared. Now, before we go over to the x squared part, let us try to find the square root, the square root first of 18. Now, for 18, as we divide this by 2, we get to have 9. So 9 is a perfect square. So we could have it this way. So 9 times 2, again, 9 and 2. Then just copy x squared. Now as you can see here, the square root of 9 is 3. And as you can see, we have here a square and we have here a square root. Remember in the expressions with rational exponents, we get to have x, then change this radical into an expression with rational exponents. So this will be 2 over 2 and it becomes 1, right? So x raised to 1 or just x. So basically all you need to do is to divide this area, this exponent with the nth root. So if you can divide it and the result is a whole number, then you extract that variable outside. It will become x raised to 1 or just x or invisible 1. Then the remaining radicand inside would be 2 because of this. And this is your answer. So basically, if I were to give you a variable with a coefficient of 1, let's just say square root of x cubed. Remember that when you divide 3 with 2, the answer is 1 minus 2, and you have a remainder of 1, right? So when you get to answer this, this would be x raised to 1. Again, why only 1? It's because our quotient is 1. But you don't need to write it anyway. And the square root of x. Now, why is there an extra x there? Because you have here a remainder. Okay, so since the remainder is 1, which signifies the exponent, so here, which is also invisible. So based on this, you get to have the answer x square root of x. Okay, another example regarding variables only before we proceed to the 7th example. Now, let's try to have square root of x raised to 5. So when you divide 5 with 2, so the answer is, the quotient is 2, then 4, 5 minus 4 is 1. Again, this whole number, or the quotient, will serve as your exponent outside the radical symbol, or the extracted root of a variable. And this exponent here would serve as your exponent of the remaining variable inside the radical, which means this would, we have here 2, right, for the exponent or the quotient of this. So you get to have x squared, then the square root of x because of this. And this is your answer. Now, let's make use of cube root. If you get to have x, as you can see, the exponent of x is just 1, so we don't need to we don't get to extract x, because 1 divided by 3 is, the result is just a fraction or decimal. Again, our goal is to have a whole number. So the cube root of x is just the cube root of x. Same thing with the cube root of x squared. Again, 2 divided by 3 is not a whole number, so you cannot extract it. So the cube root of x squared is the answer. However, if you have here the cube root of x cubed, you have 3 divided by 3 is obviously 1. There is a whole number, that's why you can extract x outside. And there's no remainder, right? There's no excess, it's just 0. That means since this one here is 0, we cannot leave any variable inside a radical, which means the radical is now gone based on that. So based on this, it's just x raised to 1, or just an invisible 1. So that means let's have cube root of x raised to 5 is equal to again 5 divided by 3, so 1. Okay, whole number of 1, remainder of 2. So again, x raised to the x raised to the exponent, which is 1, or invisible 1. Then the cube root of x, then the remainder squared. That's it. Last one before we proceed to number 7. Let's have fifth root. Fifth root of x raised to 13. Okay, let's raise to 13. So 13 divided by 5. You have here a quotient of 2, and then minus 10, and a remainder of 3. So with this, you get to have x squared because of 2, and then, the fifth root of x cubed because of 3. Okay, so that's how you factor or extract roots based solely on variables. For number 7, we have the square root of 50 x squared y raised to 4. The 50 here would be easy because it's in the first example, if I'm not mistaken. So yeah, so it is 5 square root of 2. So where am I? So we have here 5 square root of 2. I put space here for us to think that x and y could be extracted. Okay, anyway, so we have here 2 divided by 2 is 1. It is a whole number. That means x could be extracted outside. This time 4 divided by 2 is 2, which is also a whole number, which means y could be extracted. So copy y, and again, the quotient of that 4 divided by 2 is 2. So that means the answer for the square root of 50x squared y raised to 4 is 5x y squared square root of 2. Let's have the next example. Here, we have a square root of 8 a cubed b squared. Now for 8, let's try to divide this by 2. So the answer for this would be 4, which is a perfect square. So we get to have, let's have it this inside. So 4 times 2 a cubed b squared. Now the square root of 4 is 2. Let's again principal root 2. Then 3 divided by 2 is 1. You get a whole number. So extract a as well. And then no need for no need for 1 as an exponent, so just invisible. And again, 3 divided by 2 has a remainder 1, which means 1a raised to 1, or invisible 1, gets to be remained inside. And here, b squared, 2 divided by 2 is, what do you call this? 2 divided by 2 is 1. So that means it's a whole number, so we get to extract b outside as well. Now, we are left with 2 and 1a, so that means this would be a times 2, or we could write this as 2ab square root of 2a. And that's it. By the way, you may pause the video and take notes if you want before proceeding to the result or the answer of the given. Next, let's have square root of 75 x raised to 5 y squared. So let's try to divide 75 by 2. Obviously, it's not a whole number, so automatically it's not a perfect square. Let's divide this by 3. The answer is 25, and 25 is a perfect square, so that's good. So we could use this. So the square root of 25 times 3 x raised to 5 y squared. So 5 square root of 25, principal root 5. So that means 3 remains inside. Now 5 divided by 2 is 2, and which has a remainder of 1, which means 1x remains inside with the exponent of 1. And then again, 5 divided by 2 is 2. So you get to have a whole number or quotient of 2. So x squared. And then here, 2 divided by 2 is 1. So y can be extracted as well. Where am I? So 1. And yeah, wait, let me erase it too. So that's it. The square root of 75x raised to 5 y squared is 5x squared y square root of 3x. Number 10, we have square root of 200 x raised to 4 y cubed. Here 200, so let's try dividing this by 2. 200 divided by 2 is 100, and 100 is a perfect square, so we can use this. So I have here square root of 100 times 2x raised to 4 y cubed. Now the square root of 100 is 10, so extract it outside. Then square root of 2 remains inside. Then 4 divided by 2 is 2, which is a whole number, which means we could extract all x outside. So x, and then the quotient of 4 divided by 2 is 2, so x squared. And then 3 divided by 2 is, we have a whole number of 1, which is the quotient, so we get to have y. And then a remainder of 1, so we get to have y raised to 1, or just y. So based on this is our answer. 10x squared y square root of 2y. At this time, let us have examples you having cube roots. So let's have this as our 11th example. We have the cube root of 8. Now think of one number in which when you multiply that number 3 times, the result would be 8. So obviously you get to have the cube root of 2 times 2 times 2, because again, 2 times 2 times 2 is 8. Or you could rewrite this as 2 cubed. Remember what we did with square? If you have a square root of, let's just say, 5 squared, the square root can cancel a square, or a square can cancel a square root. So it just works vice versa. Anyway, going back to the cube root here. So based on this, you could cancel a cube root and a cubed. So what remains, also having the principal root alone, the cube root of 8 is 2. Okay, I hope that's clear. Next, let's have number 12, cube root of 54. So let's try. I hope you have mastered some perfect cubes from 1 to 4, 27 until 1000. Let's not get too much of the bigger numbers. Anyway, let's have 54 divided by 2, which is 27. So based on this, 27 is a perfect cube, so we could use this one. So you could have cube root of 27 times 2. Okay, so you use these numbers. So we could extract 27, the cube root of 27, the principal cube root of 27 is 3. So the answer is 3 cube root of 2. And that's it. Let's have the next example. Number 13. Cube root of 128. So no variable this time yet. Now, let's try to divide 128 with 2. So 128 divided by 2 is 64, which is also a perfect cube. So let's utilize 2 and 64. So we get to have cube root of 64 times 2. And the cube root of 64 is 4. That means the answer is 4 cube root of 2, coming from our example. Now, if you want to be sure on how this happened, similar to this area. So here, if you want to try this, so you could just write 3. 3 times 3 times 3, or cube root of 3 raised to 3. So cancel, that's why you get to have that one. Another thing, if you wanna check for 64, so you have cube root of 64, so you have 4 times 4 times 4, or just 4 cubed, then cancel, and you are left with 4. That's why you get to have this. Okay, let me just erase. Okay, next example. Let me just add, oops, where am I? So let's have here cube root of 16x cubed. Now based on this one, let's try 16. 16 is not a perfect cube, so let's try to divide this by 2. 16 divided by 2 is 8, in which 8 is a perfect cube, so we could use this one. So cube root of 8 times 2, 8 times 2, then copy x cubed. Again, cube root of 8 is 2, so we can extract it outside. 2, then this 2 here remains inside. And then here, just like what we have discussed earlier, 3 divided by 3, which is 1, which is a whole number. That means x can be extracted outside. So raised to 1 or just x. So just erase that. They're too far. X cube root of 2. Okay, by the way, since we are dealing with cube root and we still have something here left, make sure that you write 3 and 3 as well. Because if you are just gonna leave this like this, so automatically it is a square root and not a cube root. And just to be technical, this is technically wrong. So please don't forget to add the 3 here, which signifies cube root. So this is the answer from our given cube root of 16x cubed is equal to 2x cube root of 2. Oops. Yeah. Let's have a last example. Let's have number 15. Cube root of 250 y raised to 4. Now, let's try 250 divided by 2. So 250 divided by 2 is 125. So 125 is a perfect cube. So we could use 125 and 2. So equals to cube root of 125 times 2, then y raised to 4. So based on this, the cube root of 125 is 5, because 5 times 5 times 5 is 125. So 5. Now, of course, the non-perfect cube is 2, so it remains inside. So cube root of 2. Now, 4 divided by 3 is 1, and then that's the whole number, so we could extract y outside. So y raised to 1. But again, this is, what do you call this? Since 1 is should be invisible, so let's just get rid of this. Now, when we divide 4 by 3, we have a remainder, which is 1. So we have an exponent 1 for the remaining y inside the radical. So y raised to 1 or just y. But of course, this is not our final answer yet. Please don't forget that our given is a cube root. So make sure that this here is a cube root. Okay? Yeah. So this is my last example involving cube root. So from cube root of 250 y raised to 4, the answer is 5y cube root of 2y. And that's how you simplify radical expressions. Remember, factor first, take out or extract perfect powers, use the index correctly, apply the principal root, simplify completely. Now, practice consistently and you'll master radicals in no time. Don't forget to like, subscribe, and hit the bell for more math lessons. See you next time.